Hello guys, welcome back to my channel, Memo African Motives. Still working on engineering science and 3. In this case, we are going to focus on the question which is on heat on another platform. So you can consider subscribing if you are not part of the family, so that you become part of the family, Memo African Motives, as we shall be working on question papers and revisions. So we are having on question number 5, which is the first item on 5.1 is to define the term saturation temperature. Okay, the term saturation temperature. All right, so I have a definition which is it is the temperature at which a liquid boils at a fixed pressure. So the temperature that a liquid is going to boil at a fixed pressure. Normally we know that at a pressure, let's take at a normal pressure of 101.3, we are going to have let's say this is kilopascals. We are going to have a temperature of 100 degrees Celsius. Then it's now boiling. So that is actually what we are referring there as the saturation temperature, which is occurs at 100 degrees Celsius. Okay. 5.2, a steel block which with a mass of 1.5 kg is placed in an electric oven with a capacity of 10.8 megajoules per hour. The temperature of the block rises from 25 degrees Celsius to 800 degrees Celsius. The specific heat capacity of the block is 0.503 kilojoules per kg degrees Celsius. Assume that only 68% of the heat reaches the block. Only 68%. Calculate the time taken to raise the temperature of the block. The time taken to raise the temperature of the block. Okay, 4 marks for that. Okay, this one is a long story that we have there. Okay, let's just list our information. We have got a steel block here that we have. All right, which is a mass. We are given the mass of the steel block, so I'm going to use S for steel. So the mass of steel here is 1.5 kgs. Okay, 1.5 kgs. Then which is placed in an electric oven with a capacity. So we have got a capacity there of 10.8 megajoules per hour. Each and every hour is giving us 10.8 megajoules. So we can actually obtain the power here, because it's remember, power is energy over time. So we can obtain the power from this part. Power is energy over time, the energy per hour. So the energy 10.8 times 10 to the exponent of mega, remember, is to the power of 6. All right, over 1 hour. In an hour, remember that 1 hour is 3,600 seconds. The time is supposed to be in seconds, remember, so it's 3,600 seconds. All right, so using your calculator properly here, you are going to obtain please make sure that you use your calculator properly. You are going to obtain 3,000 watts. All right, this is the power that is being taken, that is being used. So we are going to talk about this later on. Let's just list our information. All right, so after that, the temperature of the block rises from, which means from, that is T1 to T2. So we've got T1 25 and T2 800. So T1, which is 25 degrees Celsius, and T2, which is 800 degrees Celsius. So this is the temperature change. And we are given the specific heat capacity of the block, which is the steel block, okay, is 0.5. We are given the specific heat capacity of the block, which is steel, so I'm just going to use S. So it's 0.503. Take note also of the units there. It's kilojoules per kg. All right, what else do we have? Assume that only 68% of the heat reaches the block. So the heat from where it is from this part that we have, only 68% is going to reach the block. Okay, so I'm going to talk about that. Then calculate the time taken to raise the temperature of the block. So we need the time taken to raise the temperature of the block. Which is the block that we are talking about? We are talking about the steel block here. All right, guys, we are given that 68% reaches the block. So what let's start by first having the energy actually that was taken, because if 68% is going to this is 68% of the energy actually, so we need the energy that is going to be affected here, the energy that we have from the steel block. We have got the mass, the change in temperature, and the specific heat capacity. So it means the energy that is going to be obtained there on everything is going to be M. Remember, it's mass times the specific heat capacity times the change in temperature. So this is the mass of steel, the specific heat capacity of steel. All right, but this, guys, is not the answer. Remember that 68% is taken, or 68% is the one that reaches. So we are going to multiply by 68%. So 68% is 68 over 100. Everything that you're going to have, which is as a decimal, it's 0.68. Okay, 68%, to remove that as a decimal, is 68 over 100, which is 0.68. All right, so let's substitute our values. Let's substitute the mass for the steel bar or the block, which is 1.5. So it's 1.5 multiplied by the specific heat capacity, the specific heat capacity of steel, which is 0.5. 0.3 multiplied by the change in temperature. Okay, so the temperature changed from 25 to 800. So you subtract T2 minus T1, that is the change in temperature. So it's 800 minus 25. 800 minus 25. Okay, whatever that you're going to get, you multiply by the what? By 0.68, which is this one, 68 over 100, which is 68%, which is being used. Okay, so this part alone, without the 68%, it is going to give us 584, if you multiply properly, 584,7375. All right, which is in kilojoules. Then you multiply by 0.68, which is the one that is taken from the percentage. So you're going to have something like 397,6215 kilojoules. All right, so this is the energy that you are given. Why are we calculating the energy? Someone is actually asking, why are we calculating the energy? Remember, we want to calculate the time. And I given you here that the power that is used is 3000 watts. So if we are using a power of 3000 watts and the energy that is there for that power is this one, what is going to be the time that is taken? We can actually determine the time. If we are given the energy, we are given the power, and we want to calculate time, we can actually find the value of the time using which concept or which formula can we actually use in this case. Okay, we know that the power is equivalent to energy over time, just like what we obtained this part here. But this time we need the time, so we are going to make T the subject. Okay, so the power, we've got the power of 3000 watts. So 3000 watts is equivalent to the energy that we calculated here, which is this one. So you've got the energy, which is 397,6215 kilojoules, which is times 10 to the power of 3, that is kilo over the time, like this. All right, so how can I calculate the time here? I can just cross multiply and apply my mathematical skills. So it's 3000 t, which is equal to 397,6215 times 10 to the power of 3, like this. Then you divide by 3000. All right, so divide by 3000. At 3000 here, you're going to obtain the value of t, which is now this part, or you could have just made t the subject here. Pt is equal to E divided by P divided by P. So T is equal to energy over the power. So you can just do that, okay? So if you are to use your calculator properly, you're going to obtain 132,5 seconds. Okay, so this is time. Remember, time is going to be measured in seconds, just like what we did here. Is this part? No, it's not that one, but it's this one, what we did here. When we said we had a time of 1 hour, then we had to convert this time to seconds. So it means whenever you use this formula, you are going to obtain your time in what? In seconds. So this time is going to be in seconds. So that's how we actually obtain such typical questions. So let's see another one that we had on 5.3. We have got an engine. An engine has a brake power of 16.2 kilowatts. The engine is subjected to a brake test for 40 minutes. The mass of the fuel consumed is 2.25 kgs, and the heat energy of the fuel is 32 megajoules per kg. So remember, the heat energy is actually equivalent, or it plays the same role as the heat value. All right, so let's take the information. The brake power, this is 5.3. So we are given the brake power. I'm just going to write it as BP, which is 16.2 kilowatts. All right, what else do I have? The engine is subjected to a brake test for 40 seconds. So this engine is subjected to a test of 40 seconds, which is the time, 40 minutes actually, not seconds, but this is 40 minutes. Then what happened after that? The mass of the fuel consumed. Okay, so this is the fuel. Let's talk about the fuel here. It has a mass of 2.25 kgs. All right, 2.25 kilograms, which is kgs. All right, and the heat energy, which is like the same thing as the heat value, is 32 megajoules per kg. Okay, so this is 32 megajoules per kg. All right, so this is the information that we are given. Then the first question is to calculate the following. Okay, so what are we calculating? The first one is the heat energy released by the fuel. The heat energy released by the fuel. We all understand that when we are given the mass of the fuel and the heat value of the fuel, you can actually calculate the heat energy that is being released by the fuel. Which concept are we using here? We know that the heat energy is equivalent to mass times the heat value. I think I have talked about this formula some time now. All right, so let's substitute the mass that we are given of the fuel. Take notice about the fuel here. So it's 2.25 multiplied by the heat value, which is the one that we are given as the heat energy, which is 32 mega. Take note, it's megajoules. All right, so if you multiply properly, you're going to obtain 72, which is in megajoules, because you used megajoules, so this one is going to be megajoules. Okay, so that is your energy there. Then the equivalent power of the engine, the equivalent power. All right, the engine here has got something that it has. Let's take this aside. We are given the brake power. We are not talking about the brake power. We are talking about the equivalent power. So we know that whenever you've got energy, power does not change, guys. It's energy over time. Power, energy over time, which is the heat energy released by the fuel. Okay, so what are we having here? The heat energy released by the fuel, we obtained it 72 megajoules, which is 72 mega, guys, I told you, is times 10 to the power of 6 over the time which was taken, which is 40 minutes. Remember how we converted minutes, how you convert minutes to seconds. In a minute you've got 60 seconds, so you're going to multiply this by 60 because you've got 40 minutes now. So it's 40 times 60. So you're going to multiply 40 times 60 like this. Your time is now in seconds. Remember, your time is supposed to be in seconds. Okay, so if you multiply and divide, you're going to obtain 30,000 watts. So this is the power which is measured in watts. And we know that 30,000 watts is simply, these 3 zeros represents kilo. So it's going to be 30 kilowatts. So you can write your power as 30 kilowatts. So the equivalent power is the normal power that you are used to, which is 30 kilowatts. All right, so that is what you have in this case. All right, then on 5.33 we now need to have the efficiency of the engine. All right, efficiency of the engine, we know that always efficiency, that is 5.33. all right, efficiency is always output over input, so we're going to work with output power over input power times 100%. that is the efficiency. So what is going to be your output power? The output power in this case is the brake power. That is your output power over the input power, which is the normal power that was taken by the engine, which was released by actually the one that the engine was producing, so was taking, then it releases the brake power, which is the output. So, or another thing that you can actually do in exam, guys, this is another trick that you can actually use. Always this value here, the output, because efficiency is supposed to be less than 1. No, guys, normally efficiency, we can't have an efficiency which is greater than 1 on a normal case. So your efficiency is supposed to be less than 1. So to obtain less than 1 in terms of a normal number, but as a percentage, it can be less than, we are just talking about less than 100%. Okay, less than 1 as this part. When you simplify this part here, you're going to obtain less than 1. Then as a percentage, you're going to obtain less than 100%. So there's no way for you to obtain less than 100%. This is supposed to be the smaller value. You're supposed to have this as the smaller value, and this is supposed to be a bigger value. That is how you can actually cheat this question in exam, because maybe you forgot the formulas and so forth. Know that the smaller value is supposed to be on top, the bigger value on the bottom. That is for you to have a percentage that is less than 100%. Okay, but in this case it's brake power over the power. Okay, so this is your brake power, which is 16.2 kilowatts. Okay, so we've got 16.2 kilowatts over the power that we obtained here, which is 30 kilowatts. Okay, so this is this is kilowatts, so these are going to cancel, so you cannot write them. Okay, times 100%. So as you can see, what I was saying, the smaller value, the bigger value, the bigger. So you can actually cheat this question like this in exam if you maybe got confused, or you are not knowing the formula. That's what you can do. Okay, so multiply this from the calculator, you're going to obtain 54%. So this is the efficiency of them. As you can see, it's less than 100%. Efficiency is supposed to be less than 100%, and it's only a condition that the smaller value should be on top, the bigger value on the bottom, just like a normal fraction. Just like, guys, you write a test, you can't obtain 5 out of 4. you obtain 4 out of 5. So it's the concept, the bigger value on the bottom, smaller value on top. That's how you can find a percentage, isn't it? So you can actually use the concept, smaller value on top, bigger value bottom. You won't lose anything, because what they need there is the mark, is answer from a working. So that working is enough for you to get 2 marks by just writing that. Okay. Then on 5.4 we are given complete the table by writing down the missing values A to C without referring to the STEAM tables. So in this case, no STEAM tables, but this information is of STEAM tables, but they do not want us to use STEAM tables. They want us to join those together to find one value. Okay, so the first one is next to the question number 5.4 in the answer book. Okay, so let's analyze the table here. What's happening? So the first number is A. We are given a pressure in kilopascals. Remember, your pressure is supposed to be in kilopascals. So at a pressure of 40, the enthalpy of the saturated temperature is, we are going to have here is 318, which is the enthalpy of H, which is HF, is 318 kilojoules per kg, HFG, and we need HG. Here on B, we are given a pressure of 180 kilopascals. We are given HF. You do not have HFG. You have HG. So how are you going to determine the missing values? You are going to use this relationship. I talked about this in another episode on heat also, that you can calculate this by using the formula of HG of the dry steam, which is equivalent to HF plus of the enthalpy of what? Of evaporation. All right, so this is dry steam evaporation that you're having. So you can make the subject of anything from this formula. Okay, so let's start with this one. The first item, A, we want to calculate Hg at a pressure of 40. Your HF is 318. So Hg is going to be HF, which is 318 plus HFG. Okay, this is your HFG, which is 2319. 2319. Okay, so if you add properly, you are going to obtain 2637 kilojoules per kg. Remember, these are in kilojoules per kg. Okay, so that is the first part on A. So the question was for you to fill in, so you're supposed to fill in on your answer book. Okay, so you fill in on item 1. So this is our 1. Okay, let's move on to 2. Or another one on B. So this is 1, which is on A. Then we move on to B. All right, on B you are given HF, you are not given HFG, and we are given HG. So we can make the subject to make HFG. So from this one, if you make HFG the subject, we are going to transpose this to this side like this. So it means HFG is going to be HG minus HF. So you can substitute again HG, since you have got the value of HG here. Your HG is 2702. 2702 minus HF. Okay, your HF is there, which is 4492. That's HF 492, like this. Okay, so if you subtract these two, you're going to obtain 2210, which is in kilojoules per kg. Okay, so that's our HFG. All right, let's move on to C. On C, what are we given? On C, we are given HFG. We want to calculate HF. So simply, you're going to make HF the subject this time. So which means you're going to transpose HFG this time. So it's going to be HG minus HFG. Okay, so HF is HG minus HFG. So using that one formula, you can find whatever that you want. So this is your HG here, which is 2744 minus HFG. This is your HFG, which is 2117. All right, so let's combine and see what you're going to have in this case. So if you combine properly, you are going to obtain 627, that's 627 kilojoules per kg. All right, as the HF. So that is how you are supposed to answer this question. So as you can see, these are actually typical questions that you can find on HEAT, and they will be carrying a lot of marks. So as you can see, this question was actually having 15 marks, everything there, and you can't afford to lose all these marks, guys. So anyways, that's it on HEAT, working on past exam papers and revisions for Memo African motives. Still revising, guys, so let's just continue to work on more question papers and revisions so that we prepare ourselves for the exams which are ahead of time. So that's it, guys, till we meet again.